All right, let's dive in. Today, we're going to pull back the curtain on some of the real unsung heroes of our digital world. We're talking about the tiny, fundamental components that honestly make everything you do online, from streaming a movie to just browsing the web, actually possible. I mean, have you ever really thought about this? How in the world can we send countless TV channels, phone calls, and all that internet data through just one single cable, without it all just turning into a jumbled mess? It sounds impossible, right? It's kind of like trying to shove 1,000 cars onto a single lane road all at once. You'd expect a total, chaotic data traffic jam. So the big question is, how does our world avoid this massive digital pileup? Well, the solution is, honestly, it's pretty elegant and it's surprisingly simple when you break it down. Just picture this. On one end, you have a device that neatly takes all those different signals and weaves them together into one single combined stream. Then that stream zooms down a single cable. And on the other end, there's another device that carefully unravels everything, sending each piece of data back to where it's supposed to go. It's like this perfectly organized round trip for all our information. So, what do we call these amazing little data traffic controllers? Well, meet the stars of our show, the multiplexer, which we just call a MUX for short, and its partner, the demultiplexer, or DMUX. These two little circuits, they're basically the beating heart of all modern data transmission. Okay, so first up, let's talk about the multiplexer, or MUX. Its job is really straightforward. It's what we call a many-to-one device. You can think of it like a digital gatekeeper. It sees a whole bunch of different data signals, all trying to get through the same door, and it just selects one at a time to let through a single exit. And then, on the other side of the line, we have the demultiplexer, the DMUX. And you guessed it, it does the exact opposite job. It's a one-to-many circuit. It takes that single stream of data that the MUX sent, and it acts like a data distributor, basically pointing that data to the correct exit out of a whole bunch of different options. So yeah, this really lays out their relationship perfectly, right? The MUX combines signals, the DMUX separates them. One's the data selector, the other is the data distributor. They're really the perfect digital partnership, like two sides of the same coin, designed to work together in perfect harmony. Okay, so we get what a MUX does, but how does it actually choose which signal gets to go through? Let's take a closer look and see this data combiner in action. All right, here's a super simple example, a 4-to-1 multiplexer. You can see you've got four separate input lines, we'll call them A0 through A3, and they're all competing to get access to that one single output line, called Y. But here's the thing, only one can get through at any given moment. So who or what decides who wins? The secret? It all comes down to these things called select lines. And that's exactly what they do. Think of them as the traffic cops. They receive a command, basically a little binary code, and based on whatever that code is, they open the gate for one specific input line and tell all the others to wait. And this truth table here, it shows you the exact logic. It's super simple. If the select lines, S1 and S0, are both set to 0, then boom, the MUX picks input A0. If S1 is 0 and S0 is 1, it picks A1. You get the idea. Every single combination of those select lines points to exactly one input. It's a simple and totally foolproof system. And you know what's really cool? If you peek under the hood, it's not magic. It's all just a really clever arrangement of the most basic things in electronics, AND gates and OR gates. This function that seems so complex is actually built from the simplest possible building blocks. It's just incredibly elegant and efficient. And this is where it gets really powerful. This shows you just how scalable they are. What if you need to handle more data? No problem at all. These circuits are basically digital Lego blocks. You can literally just snap two 4-to-1 MUXes together, add one more small one, and you've built yourself a bigger 8-to-1 MUX. You can just keep building them up to manage more and more data. Okay, so that's how we combine the data. Now, let's jump to the other end of the line and see how the demultiplexer completes the system. How does that single stream of data get sorted back out into its original parts? Now, this should look pretty familiar, just, in reverse. Here we have a 1-to-4 DMUX. We've got that one single input line, I, carrying all the combined data. So the challenge now is to figure out how to route that data to the right destination. Is it supposed to go to Y0, Y1, Y2, or Y3? So how does it know where to send it? Well, once again, it's those trusty select lines. And here's the genius part. The DMUX uses the exact same binary code that the MUX used on the other end. So if the MUX used 00 to pick a certain input, the DMUX uses 00 to send that data to the right output. It's a perfectly synchronized dance. And just like its partner, the MUX, if you look inside, it's all just simple logic gates. It's another beautiful, efficient design that gets our data exactly where it needs to go, every single time. Okay, so we've seen how they work, but the real question is, why does any of this matter? I mean, why should we care about these tiny little switches? What's the big deal? The big deal is that they are absolutely everywhere. Seriously, every single time you browse the internet, you are using a MUX and a DMUX to send and receive information. They're deep inside your computer's memory, helping the processor grab the right data. Heck, they're even in your TV, and they're what let you switch between your PlayStation and your Chromecast. Yeah, the source material really hits the nail on the head here. These things aren't just useful, they are essential. Without MUX and DMUX, our entire ability to move data around efficiently would just stop. It would grind to a halt. In a way, they're the perfect example of a core engineering principle. You take a massively complex problem and you solve it by breaking it down into simple, manageable steps. So next time you're streaming a movie or hopping on a video call, just take a second to remember these little guys. The MUX and DMUX are basically the divide and conquer strategy made real. They're the silent conductors of this massive digital orchestra. They take what should be a chaotic flood of information, they organize it, send it on its journey, and then reassemble it perfectly on the other side. It's this incredibly elegant way of managing complexity that makes our modern digital world even possible. And that leaves you with a pretty wild thought, right? As these fundamental little switches get even faster and more powerful, what incredible new things will they allow us to do next?